Now we'll take a look at addition and subtraction of monomials, and we're going to use something called like terms. Like terms have the same variable part raised to the same power. So for example, 2x squared and 3x squared are like terms because they have the same variable, they both have x, and they're both raised to the squared powers. We have 3x cubed y to the fourth and 4x cubed y to the fourth. These are both like terms because they both have x cubes and y to the fourth. Now here is an example of not like terms. A squared, x squared. They both have the same power, but they have a different variable, so they're not like terms. 3x squared, 2x cubed. They both have the same variable, but their powers are different, so these are not like terms. Things that we can do with like terms are we can combine them, and we combine them by adding or subtracting. And what we're going to add or subtract is the number that is in front of the variable. And that number is called a coefficient. So the number that is in front of a variable is called a coefficient. So if I have 2x squared plus 3x squared, all I'm going to do is add that coefficient, and that gives me 5x squared. Notice, I do not do anything to the exponents when I am adding. Before, when we were multiplying things, that is different than saying 2x squared times 3x squared. In this case, I would go 2 times 3, which would give me 6, and I would go x squared times x squared would give me x to the fourth. I would add those exponents. And that is different when I am multiplying from when I am adding. So notice that. Those common mistakes students make are messing these two up. Okay, here's another example. 4x cubed y minus 2x cubed y. Are they like terms? Yes, they both have an x cubed y. So I'm going to go 4 minus 2, and I'm left with 2x cubed y. Now sometimes you might have examples that have multiple operations, and all of these would say simplify, so you will need to know what to do with these types of problems. So when I look at this and I'm going to simplify, I see, oh hey, this is all multiplication. So what do I know about multiplication? Well, I know that first I'm going to do what's up in my numerator here, and I'm going to go 2 times 6 and I get 12, and x squared times x cubed, when they are multiplied, I add the exponent, so I get x to the fifth. And y times y squared, this is the same as saying y to the first. I'm going to add the exponents, and that gave me y cubed. And this was being divided by 4x squared y. Well, now I can look and say, hey, it's still all multiplication and division, so I'm going to go 12 divided by 4, that gives me 3. X to the fifth divided by x squared, that gives me x cubed. And y cubed divided by y, I'm going to use that subtraction rule. This is the same as saying y to the first. And 3 minus 1 gives me 2. And that is different from a problem that looks like this. Well, here I'm going to say this. 30x to the fifth divided by 2x squared plus 12x to the eighth divided by 3x to the fifth. These are not like terms right now, but what I notice is I can do division. So I'm going to go 30 divided by 2 and get 15, and x to the fifth divided by x squared, and that will leave me with x cubed, plus 12 divided by 3, that gives me 4, and x to the 8th divided by x to the 5th gives me x cubed. Now I'm going to look at this and say, can I simplify this any further? And the answer is yes. I have like terms here. These are both x cubes, and I'm adding them, so when I add them, I just add the coefficient. So I have 15x cubed plus 4x cubed leaves me with a total of 19x cubed.